Welcome to the Tech Ed Podcast, where we visit with leaders who are shaping, innovating, and disrupting technical education. People who are not afraid to think differently, not afraid to try something new, all with the goal of securing the American dream for the next generation of STEM and workforce talent. Our guest on the Tech Ed Podcast is Mike Cicco. Mike is the president and CEO of FANUC America. As many of our listeners know, FANUC is the largest robotics and CNC company in the world. We're really excited to have Mike on board this afternoon for our discussion and looking forward to all of his insights on what is happening in the world of automation, what is happening in the world of robotics, of CNC, of technical education, and other topics. So, Mike, first, thank you so much for spending some time with us today.
Matt, I really appreciate the opportunity to be on the podcast with you.
And we appreciate you being along for the ride. You know, I think back to the first time that you and I really had an opportunity to spend a significant amount of time together was actually in Tokyo. And I don't know if you remember this. I'm sure you remember the visit. We were there for the private show in 2016. And you had just been, I think, promoted to president and COO of FANUC, and just impressed me right off the bat as somebody that obviously, number one, understood the ins and outs of a huge successful company like FANUC, but just a tremendous relationship builder, somebody that on the customer side is so effective. So I really appreciate all of those things about you. You've had an incredible journey all the way back to Bucknell and before. Can you share with our audience a little bit about how does somebody become now president and CEO of FANUC America as part of FANUC, the largest robotics and CNC company in the world?
Actually, like many people at FANUC that are in various positions within FANUC, I came through the engineering ranks. And I do think that that's a critical part of our business. We have a lot of folks within our organization that lead from example, and they lead from example of being able to do the things that we try to either sell or talk to other people about. And that's a lot of what my history was as well. I was an electrical engineer at Bucknell University, as you mentioned, in Pennsylvania. I had a passion for manufacturing really since the beginning. I did a short stint at Northrop Grumman right out of school and then transferred to Bucknell and was a software engineer for many years at FANUC. And within that, I got to know all sorts of different industries. I was at our California office in Southern California, and I was able to work in the automotive components business, the aerospace business, the food and beverage, consumer products. I mean, you name it, there's a lot of manufacturing that's done out there. And so you got to learn by doing. I realized that I also kind of had a mixed passion, not only for doing the technical stuff, but also for just fundamentally helping people and companies reach their goals. And that pushed me towards the sales side of the business. And I did that directly for a few years. And then I realized that what a really good mix of those two things is working with system integrators. And that's really where I spent the bulk of my time at FANUC, is growing and developing and leading system integrators. Fast forward a few years after that, and getting back into my engineering roots, and then switching to the automotive side for a few years, and became president a couple of years ago. So it's been a nice ride, but I will say that having the engineering background and actually doing the work at FANUC is what really has helped me throughout this process.
And we talk quite a bit about how people are inspired toward STEM careers, toward careers in technical fields. Was there a moment, was there a time when you decided I want to be an engineer? What led you on that career and to choose that major and that pathway as you thought about your next step in education after high school?
If there's younger kids listening to this, so you could be familiar with it, that I was probably in late grade school or maybe in high school when I realized that I liked taking things apart and seeing how things work. My dad's a doctor, and I always felt like maybe being a doctor was what the path should have been for me, because that's what I grew up with at home. And then I came to recognize that I just like taking things apart. I took a TV apart to try to figure out what was wrong. I wanted a cable TV in my room, so I went up in the attic and rewired the cable box to feed cable into my room. And that started driving me towards the career in engineering. And to be honest, what's available to kids today, if that was available, now it's been 20 plus years, almost 25 years since I graduated college. So we're pushing 30 years since I was in high school. But if some of the programs that are available today were available back then, I certainly would have taken this route of being in manufacturing, but it could have happened in many other different paths in terms of going in and learning about robotics in high school, or taking a community college route, or getting right into industry right after some level of a certification. So I took the path that I took, but it's much different now than it was back then.
Well, it's an interesting pathway. You know, it reminds me a little bit, Mike, of conversations with my wife, Renee. She's a master's degree engineer. She says exactly the same thing. She said, boy, if I had to do it over again, number one, way more hands-on STEM in high school, and then getting into her next step, which was earning her bachelor's degree right out of high school. She said same thing. She would consider going to a community college, getting those hands-on opportunities, really getting a context for engineering content, for engineering curriculum as she moved on to her 4-year degree. We'll dive in a little bit later into all the great things that FANUC is doing in the education space, but certainly you've got a huge friend in terms of your commitment to understanding the importance of inspiring young people toward these amazing careers in STEM and giving them the right experiences when they're in high school. So it's been a little while since you graduated from high school, not quite as long as since I graduated from high school, but tell us a little bit, Mike, if you would, in terms of your view of success, rising to the level that you have within FANUC. How has your view of success changed over the years as you move forward in your career?
It's a great question. My view of success is first even being able to recognize or highlight to somebody a better way to do something, and then through that be able to see it to completion. When people ask FANUC what we do, we always say the same thing. We always say that we solve manufacturing challenges. And really for the past 20 plus years, that's what I've been doing. And so my view of success is still being able to do that. We get out there and we solve manufacturing challenges. And the great thing about that statement, I think, as a company mantra is that it can take a lot of different forms. So, maybe somebody's challenge is that they don't have the right skilled workforce for their organization. And so the way that we can solve their challenge is to work with them on an educational program to bring in the right manufacturing workforce. And then maybe some of it is they have a job where the operation that they do is a very dangerous operation, and we can find some way to automate that and help them reduce the labor or reduce workplace injuries or take on something that's monotonous that they can't find labor for. So to me, my level of success has been the same. How I've solved that has been different over the years. I used to physically get in there and solve those problems myself, and now I lead a team of people that are able to do that. But I think the gauge has still been the same throughout the time that I've been at FANUC.
And that customer-centric idea of solving manufacturing challenges for customers isn't anything new for FANUC, is it? It goes all the way back to your founding as a company. We learned last month, sadly, that Dr. Esanaba, the founder of FANUC, passed away at the age of 95 in Tokyo. A great long life, and what an incredible legacy that he leaves, not just across manufacturing, but literally every segment of our economy across the globe. What can you share with us about Dr. Esanaba's legacy?
Thanks for the condolences, Matt. Dr. Esanaba, I just gave a company meeting yesterday, and we reflected on his impact. And I said very plainly during that meeting that none of us would be here. And I was speaking to our employees at FANUC. We obviously wouldn't be here without Dr. Esanaba's brilliance and his dedication to the industry. But really, I can more broadly say that many of us, you included in your background in manufacturing, may not be in the position that we are without Dr. Esanaba's vision and passion. So for those of you listening that don't know, Dr. Esanaba was the inventor of the modern day CNC. And his imprint on manufacturing is so big that without that work that he did, you can think that there wouldn't be CNC machines the way they are today. And then he also had the mindset to be able to not just take what he thought and felt from a CNC perspective and put that into one singular machine, but he had the brilliance to produce the CNC control and enable as many builders that wanted to be able to use that control, which spread that technology through the world very quickly. And then he had the future mindset to partner with industry leaders like General Motors to get into the robotics business, or General Electric, GE, to broaden their spectrum on the controls business. And then he had the foresight to mutually pull out of those joint ventures at the proper time and bring FANUC to the next generation. So who knows what the future would have looked like without Dr. Esanaba, but I can tell you manufacturing and advanced manufacturing definitely would not be the same without his passion and knowledge in the industry, starting with the invention of the CNC control.
And he will be sorely missed without question, but what an incredible legacy to leave behind. And really going all the way back, as you suggest, to the invention of the CNC. And you're right, my days in manufacturing, CNC wire bending, CNC machining, CNC water jets, I mean, all of that technology literally across the globe. And not just the way we manufacture, but the cost at which we manufacture, the products that we're able to deliver to consumers at a reasonable price. All of that in so many ways had their roots in his vision and his ability to build truly an amazing company. And and as you suggest, moving through automation and into controls and building incredible relationships. On that topic, in terms of the evolution of manufacturing technology, we're seeing a lot of interest now in automation, in robotics from some of the economic sectors that maybe in the past weren't as automated. So we're looking to things like e-commerce with the tremendous growth in the world of e-commerce, especially in the wake of the world pandemic and the COVID crisis. That's one market that we see changing like crazy. The effect of automation on global supply chain. So what can you share with us about the future growth of automation in robotics and in other technologies as you see it?
We've seen tremendous growth, as you mentioned, in a lot of new areas. When we look at how to segregate the business, traditionally we break it down really into three areas. We say there's automotive business that we automate, there's automotive components. So even within automotive, we break that down into two. But then historically, we've broken down the rest, basically everything not automotive, we say is general industry. And I think we did that because the automotive and the automotive components business were such large chunks of the pie that it was just easier to break everything out into just that general industry. But over the last few years, really since the recession, so now we're going on 10 years, that piece of general industry business has really grown well above and beyond those either two pieces. So automotive and automotive components still represent large chunks of our business, but the totality of general industry is growing and has been the fastest growing portion. And I think that's for a lot of reasons. Number one, that the recession took a lot of the workplace out of manufacturing. I think the recession coupled with the baby boomer demographic took a lot of skilled people out of the workplace. And that had led to then the people really looking into advanced manufacturing and automation as a way to keep their businesses going. And then the level of production in those areas has continued to grow over time. So that all led to a lot of advancements in advanced manufacturing in that general industry. And then the world's always changing. And so you mentioned e-commerce as being one of them. You may rewind back 10 years to the Great Recession. None of us could have foreseen what the e-commerce market looks like today. And we're fortunate to be in the position we are, but to be able to add this level of advanced automation into that business, because they wouldn't be able to process that many packages or mail that many shipments without the advanced manufacturing that's in there. So we're fortunate to be a part of it, and we're adding intelligence every step of the way to the process, especially in the e-commerce side.
Absolutely. Adding intelligence both in terms of people and in terms of technology, right? It's been fascinating to see how smart technology is involved in manufacturing. Mike, I want to talk a little bit about partnerships. You referenced already some of the great partnerships that FANUC has had over the years. Rockwell is a great company. I know you've worked really, really closely with Rockwell over the years. Rockwell, some of the other OEMs that you see doing really, really innovative things in the world of advanced manufacturing, smart technology, automation. Who should our listeners have their eyes on the next couple of years that are doing some innovative things?
You want to look for industry leaders that affect manufacturing. An industrial robot, something that FANUC makes, an industrial robot, or say a CNC control for a machine, there's so much more on the factory floor than just those things. And so it wouldn't be advantageous to us to think that we could go in and affect everything just as FANUC. And so the partnership with Rockwell has really blossomed, and it makes sense because in the market here, they're the leader in control technology. So the high market share leader in PLC technology, motors and drives for machines on the factory floor. In addition to that, you think about what a robot needs on the end of arm tool from a gripping technology, or even the chucks on a CNC machine. And so our relationship with Shunk plays a lot into this as well. And obviously, there's a lot of different ways to tackle business once you get onto the floor. There's other robot companies, there's other PLC companies, but we just try to align ourselves with market leaders and try to get into companies together. For those of you listening that have ever visited FANUC, first of all, if you haven't visited FANUC, an open invitation to come visit FANUC at our headquarters in Michigan. We have a lot of cool demos all throughout our floors. And that's where you'll see some of those partnerships take place, because the demos represent both the robot, the controls, plus all the peripheral equipment that you'd see that you need. And so that's where a lot of our partnerships take place.
It's amazing. And I've been to your facility in Rochester Hills several times. People see things there that they won't see anywhere else. They'll see applications of automation and vision systems and other technologies, artificial intelligence, machine learning that they won't see anywhere else. So would certainly join you in encouraging our audience to make that trip. It's absolutely amazing what you have the opportunity to learn. And on the topic of those last two technologies that I mentioned, artificial intelligence and machine learning, a lot of folks are still wrapping their brains around what that even means and how it manifests itself both inside and outside of manufacturing technology. What can you share with us about, how FANUC views those technologies and what their impact on the world of automation will be in the coming years?
Yeah, you're right about those terms. I think that they get thrown out all at the same time. It's like one big sentence. People just say AI, machine learning, and throw in an Industry 4.0 there, and you've got like the trifecta of things that people say all the time and maybe don't know what they mean too much. But specifically about AI and machine learning, to me, the way to simplify it all comes down to ease of use. What we're trying to accomplish is more and more, we're trying to get robots and automation to do more and more complicated things. You can throw out that term AI or machine learning, but what we're striving for is a way that the system itself is taking on more of the complex things so that you don't need a PhD level software engineer to program a robot in a factory environment. So that's maybe the easiest way to break that down. If you can imagine, one of the hardest things for a robot to do is get presented with a random bin of various parts. But in manufacturing, that happens all the time. It could be a bin of raw castings if you're doing machining. It could be a bin of consumer products if you're in e-commerce. People are very good at taking those packages out one at a time, or those parts out one at a time. But the problem is that's a really repetitive, boring, kind of not that great of a job. And so that's an area where people are looking to automate. But in order to program a robot to do that, to go look at a bin full of random parts and to identify each one of those and to find the right place to go or to know what package I have is really, really complicated. And that's where we are developing AI and machine learning to simplify that process. And so from the user experience, maybe you're telling the robot what's in the bin or you're telling the robot where the bin is, but then a lot of the AI and machine learning kicks in and simplifies that process where it's behind the scene, it's behind the curtain, where the robot's figuring out what to do without a lot of interaction with the user. And that is going to help us get into more areas of manufacturing by simplifying that process.
And just another example of how FANUC continues to innovate across emerging technologies. This goes back a few years, Mike, but I remember a trip to the Customer Experience Center and to your product development area specifically. And that was when FANUC was just announcing its brand new version of a collaborative robot. And at that time, I think a lot of people, their impression of what a collaborative robot is was more about how it looks, right? Everybody expected that it should look like a person, that it should act like a person. It's really more about application. It's really more about the robot's ability to interact in close proximity to a human being and do so in a safe fashion. I had the opportunity to present yesterday to IMTS Spark. Another opportunity missed to see Mike Cicco this year was there was no IMTS in Chicago. But so it's all virtual. And I presented to that group yesterday and talked about collaborative robotics. I've learned so much from FANUC about that whole space, about the applications, going back, as I suggested, several years to what people see as the green robots, the collaborative robots. Now the new CRX, which, as I mentioned to you, is a total game changer. So on that whole front of collaborative robotics, some of the latest additions to FANUC's product lines, how are collaborative robots changing the world of automation?
Yeah, I think a lot of the same lines from what you said. It opens up an area that had been closed off for automation for us. If you rewind back to the earlier times of when people started to automate, you looked for the biggest, heaviest, most dangerous areas, and you had a big fence with a robot in the middle of that fence, and the people were very segregated from that area. And then through some software advancements in safety, you were able to get that fence down smaller and smaller, but the robot was still within a cage. And so the robot needed to do the robot things within the cage, and then the people needed to do whatever people were good at outside of that. And you had to connect those things with conveyors or other things to get the parts back and forth. And so to the question of how are collaborative robots changing, I think that the nature of the collaborative robot and being able to be so close to the people, what it's allowed manufacturers to think of is, let's think of all the things that the robot could excel at. And then in the same mindset, think about what the manufacturing worker would excel at. And we can blend all those things together within the same work cell and utilize a collaborative robot to do everything together. And so we've seen a lot of operations where maybe there's some detailed wiring that needs to take place on a motor housing. This is big in the electrical vehicle market right now, where you have these big, heavy, whether it's a big, heavy battery or a big, heavy motor, something that's hard for a person to move around. But the wiring of that or the configuration of that requires skilled labor to come in and do those things. And so you blend those together. You get a collaborative robot to pick up the thing that's heavy. That's the thing that's hard for the person. And then you present that to a person that does the thing that the person's good at. And it's a perfect symbiotic system there. So I think those are the areas where collaborative robots are changing the world of automation. And then you touched on the ease of use piece of it as well, where because collaborative robots are naturally kind of easy to use and easy to program, we're seeing robotics and automation penetrate into much, much smaller shops. So very, very small do-it-yourself shops that people are starting to use collaborative robots and automation as well. And that's been a big benefit, I think, to a lot of manufacturers out there.
And I know our listeners will be excited to know that the collaborative robots are now alive and well in education as well, with both some recent introductions from FANUC with the CRX and also with the CRs, the green collaborative robots that have been around now for a couple of years. And we see more and more educators now teaching this technology as well, which is really, really fascinating. And I think the opportunity for students of all ages to have exposure to a variety of robots, to a variety of applications. Again, going back to our whole idea of how we get more young people excited about careers in manufacturing, just shows how this whole world of automation and robotics is evolving into a really, really cool career pathway. And not that manufacturing career pathways weren't cool in the past. You and I both chose them. They were cool then. Maybe fewer people recognized it, but now with the advent of all the technology that young people get to work with, it's really advancing. And I want to recognize FANUC's foresight in the whole development of your CERT program, the theory or the flavor, if you will, behind that program. It's really about getting people excited about technology, giving them the skills and competencies they need when they get to the workforce. And I think that that's really been unique. I mean, there's a lot of newcomers to the world of education. There's a lot of companies out there that are just trying to find a way to squeeze their way in so they can sell more product. And that's never really been FANUC's approach to its CERT program. It's always been about the student. It's always been about the educator. And FANUC was first to the game in this. I mean, going back several years, FANUC was building out a education-specific distribution channel, building out an incredible group of people at FANUC that focus on the education space. Can you talk a bit, Mike, about what led FANUC to be such a pioneer in the world of education when it comes to automation and robotics, and what led you to make such significant investments in that space?
Yeah, Matt, I'll talk about a couple levels. First and foremost, my predecessor, Rick Schneider, led the effort originally, and I've taken it up since then. I think the reason why we got into it is from our customers. They didn't know they were telling us to, but they were telling us that they needed it because every place we went to try to help people, we'd start the conversation of what's your biggest challenge? And finding people was the biggest challenge. And at first it started with sometimes it was, finding people to do some of the skilled trades. And then as we started talking about the automation piece of it, and then the conversation quickly morphed to, we don't have people that know those things. And time again, one of our biggest challenges was I would be able to sell something to somebody if I could provide a technician that came with that system. And that really led us to the focus. As you mentioned, we weren't in it. We're still not in it to sell robots into schools. That's not the driving factor. It's to educate the workforce because it's needed. And we took an approach of let's find out what the schools need and what the workforce needs. And let's look at those things together and come up with a program that is good for the school and it's good for the student. And then inherently, those students are well positioned to put themselves into industry. And as that took hold, it really started to grow. And then on top of that, one of the things that I had deep experience on is our system integrator network. Why we started that system integrator network was we found that as FANUC, we couldn't be experts in all fields. Even when I was an engineer, I was an engineer on an automotive component program. And then the next day I was in an aerospace company. And the next day I was in a bakery. And we knew that we couldn't be experts in all areas. And so we started this integrator program to go out and find experts in those areas. So if we wanted to do more in bakeries, we went out and talked to companies that were experts in bakeries and taught them about robots and automation. And the same thing happened on the educational side, where every person in manufacturing, myself included, went out and tried to sell a robot to the school that they went to. So I called Bucknell and said, hey, do you want to buy a robot? We had a lot of people out there that as this started to take root, we had lots of individuals that were trying to sell robots to one school or two schools, and it wasn't the right approach. And so coming up with the experts and partnering with educational resellers that we did allowed us to really focus in on that, because that is your business. That is what you are good at. And I think that was the second key point that we took in the CERT program. So point number one is we had to listen to the customers, and coming out with an accredited program was a key part of that first part. And then focusing on companies that was your business to focus on schools and using that as the channel was the second key point.
Speaking about, Mike, finding really, really good people, finding the people that know their business, that know their space, and letting them focus on that space. I have to credit you and FANUC for building out a great team of those types of people. We have the opportunity every day to work with people like Paul Aiello and John Potter and others within your educational group. Just a tremendous amount of vision among that group as well. I don't want to leave the topic of the CERT program without recognizing all the work they've done with organizations like NACD in building out third-party certifications and really providing opportunities for a student to earn an independent certification, to go to an industrial employer and be able to say, these are the things that I know how to do. I know how to operate a robot. I know how to program it. I understand the control. Those third-party certifications have really been a key tenet of your approach to education as well, have they not?
Yes, they have. That was one of the key things that we recognized early on, where looking at each school, trying to figure it out on their own was a big struggle. So you mentioned NACD as our certification partner, and that's really driven us to that. And so a lot of hard work from Paul Aiello on our side and his team under him of figuring out what certifications we needed. The other thing is not standing still. We started with a basic certification. We leveraged that. And then now they're stackable. So you come in and you get their basic certification. You can get the next level, all the way then into a connected factory. And that brings in a lot of the industry 4.0 stuff that didn't even exist really when we were first starting these stackable platforms. It has been one of our keys to success in that the students coming out of that program can point to their certification and say, this is exactly what I learned. And it's been recognized nationally as something that's important.
And it's even going to become more and more important as the world continues to demand more and more skilled technicians with an understanding of automation and robotics and related competencies. I had the opportunity to keynote the Central Michigan Manufacturers Association annual meeting. And we talked quite a bit about what's happening in the world of skilled technicians in light of COVID. And, we hear about folks that are not able to work. The unemployment rate obviously was considerably high over the course of the summer, now coming down, which is good news. But this whole world of manufacturing, according to NAM, there were still 460,000 positions open in the world of manufacturing in the month of August. So even in spite of this economic slowdown that we appear to be pulling ourselves out of, what an incredible time for manufacturing. There's no slowdown in the need for these technicians. And with, to your point earlier, additional spaces in our economy starting to automate, there's going to be even more and more jobs that for now are going unfilled for lack of a skilled workforce. And I know that's a key focus for you and for us. What do you see as the job market for skilled technicians in the world of automation in the coming years?
I continue to see it to rise. Number one, we're becoming much more proficient at manufacturing. So every year, the efficiency level of the plants grows. You can imagine if a plant produces 100 things a day today, and if using some level of advanced automation, it can produce 150 things tomorrow. You're going to need that many people to handle all the jobs that are still within that factory that require people because they become more efficient. And then on top of that, the level of maintenance and technicians and programmers and things that come with the robots and automation just bring that job level up as well. So you mentioned a lot of the unfilled positions that are still out there, and we see that every day. And it's great to be able to walk into an end customer and say, here are a bunch of schools that are producing students that have the skills that you need. And we do that every day when people talk about unfilled positions. And then more recently, the conversation has shifted towards, how do I upskill my existing labor? So then that's the next challenge that we're getting into, is not just producing students or filling jobs with fresh students out of school, but then upskilling the existing labor as well.
And that last part is so important too. And we tell people back in the 1970s, the average manufacturing employee, believe it or not, especially if they were new to the industry, they got almost 100 hours a year of skills-based training provided by their employer at work. And today that number is 5 hours a year, and it's typically lockout, tagout, bloodborne pathogens, hazardous communication, all the things that OSHA tells us we have to train, which of course are important. But so many training programs end there and don't really realize the huge opportunity we have to upskill the people that we already have. I mean, you look 20 years to the future in manufacturing, most of the people working in manufacturing are already working in manufacturing. We already have them. How do we upskill those individuals? So that's going to be incredibly important. And I certainly share that view with you. Going back to the origins of FANUC, Mike, you mentioned how important the computer numeric control was to the beginnings of FANUC. A lot of folks think of FANUC as a robotics company, and it is an amazing robotics company. But really going back to the background, you started out as a CNC control innovator and manufacturer. How is the world of CNC going to change over the next several years? I know we have a number of instructors on board with us today and teachers that are teaching in that space and administrators that are interested in understanding what's going on in the world of CNC when it comes to technology.
Within CNC, there's a lot of new advancements. One is just the advancements in software around CNC machining, being able to produce a digital twin of a machine and do an entire replica cut path and cycle time analysis of a machine before it actually hits your floor. Those things are driving advanced manufacturing like crazy now. So people are able to really try it before they build it. We could also talk about additive as being another key growth area and using CNC within additive. There's a number of machine tool builders that are producing an additive and a subtractive machine. A lot in the repair area in aerospace or others where you might have a part that is pretty good, but you need to then build up an area of that part with an additive process and then machine that part down into the proper shape. And so that's really, really new and interesting in it, where you're not just producing the whole part again, you're growing a piece of the part onto an existing structure and then machining that off again. I know there's a lot of talk out there about the EV market and the effect that it's going to have on CNC machining overall, that if you take away all the combustion engines, how many components that is. And that's, maybe plainly said, that's the nature of manufacturing. We used to have a lot of farmers, and then we started making farming equipment, and now we have a bunch of combustion engine cars, and there's a chance that we may have a bunch of electric cars in the future. But that's kind of the beauty of manufacturing. We always find a way to continue to innovate and grow. And even today, we're looking into ways that CNC technology is useful in an EV space, and what kind of technology can we use on an electric motor, or what kind of machines are required for that type of vehicle. So I know that there's some fears out there, but I think we're going to continue to evolve. Plus, personally, I think that it's going to be a long road till there aren't any combustion engine cars too. I think that we're still going to be doing that for a while, but a lot of cool things about CNC technology. The connected CNC machine is another big area where, really, from small shops to big shops, being able to connect your machines using Industry 4.0 and look in from a distance of what the machine's up to, whether it's how many parts are produced, how efficient it is, to what the motor torque and what the current running through the motors are, to try to gauge any failures before they happen. Those are all really, really cool new technologies that exist on the CNC machines today.
Yeah, it's fascinating. And kind of going back through the list that you just shared, your team talked about the advancements in MT-Link-I and the opportunities to, gather data from CNC machines, from FANUC controls, and do some really innovative things with that data. That's going to be a total game changer. I had an opportunity about 2 years ago. I interviewed Tom Linebarger, who is the CEO of Cummins, just a fascinating guy. And we were talking about what advancements in technology technical college deans need to be thinking about as they were planning for the future of their program. Tom talked about telematics and electrification in his marketplace and how it's going to evolve. And that's just a fascinating space. Just some great things. And I know all of our CNC partners will really appreciate the insights that you had there, Mike. We promised we'd give you some time to drill me with a question or two. So I'm going to ask you one more question and then open it up for your opportunity to put me on the spot. You've really added some significant space to that plant in Rochester Hills. What can you tell our listeners about both that addition and also the significant additions that are happening in Japan at this time?
Our addition here was really about building up the amount of space that we need to service the local customers. We're up to 1.2 million square feet just in Michigan through 3 facilities here. We were fortunate enough to build a building within a walk from our existing building here, and we were able to bring all of our robot and CNC inventory into those buildings, so we didn't need to use any remote warehouses anymore. And we were able to produce laboratories in those buildings that really focused on some key needs now. So there's a dedicated collaborative laboratory. We're working on some high accuracy robots for aerospace, that we have a dedicated lab in that building. And we also were able to produce a large area of the facility that works on reliability of our painting robots. So something that the listeners may not know is we build the world's supply of painting robots here in our facility in Michigan, and we export those throughout the world. The FANUC in Japan builds material handling and welding robots in Japan. And we built a reliability center in that building where we continually test and advance the reliability of the paint robots. So it's been a great addition. We love bringing customers through. And then in Japan, they went through a huge advancement and addition of laboratories and manufacturing space over the last 3 or 4 years. So we now have the ability to produce 11,000 robots every month at our facilities. We're currently geared and staffed to produce about 7,000 robots per month, which is meeting the global needs. But we have the facilities to get it up to 11,000. We also doubled the amount of CNC production space a number of years ago as well.
11,000 robots a month. That's incredible. Obviously, no moss growing under the feet of FANUC, either in terms of innovation or in terms of physical space. Mike, we promised to give you an opportunity to drill us with a couple. So any burning questions you have for me while we're closing out our time here together?
I'm always interested in your perspective on things. You have a unique role in terms of being in business for so long. So seeing how businesses operate and then switching to the educational side, I think your perspective on it's really, really interesting. So, maybe my general question to you is the way things are today between schools and business, what has changed and what do you see that needs to happen over the next few years in terms of advancement so that we can continue to build the relationship between schools and industry?
Well, I think you hit it on the head, and it's really all about those relationships. And I can tell you, I joke about working in manufacturing and working in the education space. And I tell people, manufacturing, education, it's not that one is harder or easier. They both have their challenges. They're just different. And they're different in terms of how those challenges manifest themselves. So what we've thought a lot about is how do we work with those industrial employers to build really, really solid relationships with their educators. They don't speak the same language. A lot of times they don't see things the same way. They may have different political philosophies, all those kind of things. And what we've really worked hard at doing is helping those individuals on both sides check the agendas at the door. And let's talk about what's right for students and let's talk about what's right for employers. And it is amazing the types of relationships that can develop. And FANUC has so many tremendous relationships that have developed with educators all over the globe. We see lots of educators now engaging actively with their local high schools, with their community and technical colleges, serving on advisory boards at both of those levels, partnering in terms of sharing technology, bringing students into plants. But even more important than those plant tours, it's really advising on curriculum and thinking about how do we get these young people excited about careers in advanced manufacturing. And Paul Aiello talks at great length about the importance of inspiration and inspiring young people toward careers in our world of manufacturing. And so we really focus a tremendous amount on that. And what we find is that if we really, first of all, we tell the educators, ask for help, not money, and get the thoughts and the ideas out of the brains of your industrial partners. It's amazing how quickly a lot of those partners, if curriculum is right, if the end is right, if it's authentic manufacturing technology, they'll step up with their checkbooks and start funding those programs. And I would just add to that the fact that as manufacturing technology is evolving so fast, in my days of manufacturing, yes, we had robots, yes, we had CNC machines, we had programmable logic controllers, kind of industry 3.0 technology. Once you knew it, you kind of knew it. And anymore, it's not the world that we live in manufacturing. We can know everything we need to know about manufacturing technology today, but guess what? In 18 months or 2 years, FANUC and other innovators are going to come up with the next generation of that. So we really have to focus on curriculum, on partnerships with organizations like FANUC that can stay ahead of where that technology is going, take all of that burden off of the instructor and off of the teacher, take it upon themselves, and then show that instructor or teacher how they can continue to work the magic in the classroom. So I would say we're going to see more and more of that in the next several years, and we're looking forward to it.
Yeah, that's great. We see it every day. We see those conversations and we see inspired students. That one of the best parts of my job is to be someplace and to, once someone figures out, not even what I do at FANUC, but just that I work from FANUC, and to see an inspired student eyes light up when they see the name of the company and say, oh my gosh, I learned this or that in school and it was the best class I had. It's one of those things that drives you to come to work every day, which is amazing.
Absolutely. And some kids get to go to school and say, my dad's a policeman or my dad's a fireman, and that's absolutely amazing. And your 4 kids get to go to school and say, my dad's the president and CEO of the largest robotics company in the world, which has got to impress the kids at school as well. And who would have guessed that it would evolve to that? So Mike Cicco, thank you so much for joining us today on the Tech Ed podcast. Obviously a really, really good conversation with the president and CEO of FANUC America. Mike, we really appreciate your time. Thanks so much for taking time for us.
Absolutely, Matt. Thanks again. Thanks for our partnership too. I really appreciate it.
Thanks for joining us for this episode of the Tech Ed podcast. If you haven't already, subscribe, leave a review, and if you like this episode, share it with a friend. New episodes launch every Tuesday, so listen in next week.